we saw how those waveforms look with the IsoVu probe on the MMCX connectors, right? So that's the ideal scenario. One of the things I've seen people done, and this is not as common for VGS measurement, but people use this differential probes for VDS measurements. What I have here is a TMDP 200. This is a 200 megahertz probe, so it's not a slouch by any measure. Really good probe, but I just want to show you how this compares with a setup like this, right? To make a measurement similar, right? So we'll look at the VGS measurement, just see what it does to a measurement and see how it looks. Okay, so give me a second, I'll plug this in, we'll DISC it, and then we'll get rolling. All right, so what I did was I got this probe and I got it connected to our VGS connections on the square pin side. Right now the pins are too big, so I couldn't fit them on the pins, but that's okay. We'll get the crux of it, right? I wound the cables and all that stuff, and this is something we use all the time to make high frequency measurements. And I just want to show you how the measurements actually change quite a bit when you have setups like this, right, with long leads and just in general, the ground loops and so on, right? So let's turn this on and see what happens. There we go. All right, so remember how we saw remember how we saw the VGS measurement. So the blue signal is the VGS we are measuring on the MMCX side of things with IsoVu probe, TIVM, and the orange signal is the signal, the VGS signal, the same VGS signal on the square pin side with the TMDP 200, right? So 200 megahertz probe, and see the difference on both those measurements, right? So if I zoom in and I'll change the positions a little bit, take a look at that, right? So obviously you don't see the gate measurement, but you see a lot of artifacts that are just not there in the real measurements. That's how it should look. We just don't see it, right? So that's the problem with using differential, especially at lower bandwidth. It just slows the signal down. It works as a low pass filter, right? Just look at this, right? Even the amount of ringing on the turn off side is just crazy. It's not real, right? The problem is if you use the system to measure it, you'll have to fix for this, and it's not even there, right? So it's a measurement system problem which should not be ignored, right? So as you can see, all this ringing is not real, right? I'll show you another example with the same setup, right? So we'll replace this guy and keep the leads that I have right here, the long leads, and see how IsoVu does with long leads, right? So that is the next setup we'll. All right, so in this new setup, what I've done is I took off the differential probes, right? And what we'll do is we'll bring this IsoVu probe to this side and see how this lead length affects the measurement, right? And what I'm trying to replicate with this is a setup where we are used to soldering the cables directly to the board, right? And a lot of us do this, right, so that we can get really tight connections, right? It won't be this long, but you'll get the crux of it, right? So we are using this square pin adapter that comes with IsoVu, so you can use the MMCX tips that you have directly with this, right? So we'll save this measurement, we'll move this probe here and compare it with its own reference. Okay, so let's save this measurement in the file. So oops, waveform, and we'll call it 1 2 3 4 is fine, right? And we'll call and recall that measurement again. So right here we are looking at 5 and recall, right? So there she is, right? So you can actually see the measurement in white, and the blue measurement is now going to be the new signal, right? So I'm going to switch that probe to the new place, and let's see what the measurement looks like now. All right, there we see, right? So the blue one is the one with the leads. Let me change the trigger just a little bit so it stays kind of stable, right? So you can see it kind of matches the measurement. It's much nicer than the differential probe, right? Because it has that cable. But look at the ringing that is added just by adding this cable right here, right? So in your mind, think about this as the ring cables you use or the solders you put on the board, or even square pins and stuff like that. So anything you add to the system that takes away from that shielding is going to add problems, right? And you will be fixing for this ringing because you do not know if this ringing is real or not, right? And the worst part is if I move it, I can change it, right? So you can dial a number and you can get exactly what you want from it, right? Which is not a good thing. All right, so that's one. Now what I'll do is next we'll remove this cable and just see what square pin does to this whole measurement, right? So we'll keep the white reference right there and we'll just remove this cable. I removed the lead from the connection and we went directly with our IsoVu on the pins, on the square pin with the adapter, right? And what we want to see is how does adding an adapter and a square pin affect your measurement, right? So we already have this as a reference from the MMCX side. That is as ideal as we can get, and let's see what the adapter does to, or square pin does to the measurement, right? So let's turn this on. and take a look at that, right? So you see that right there? I'll move this so it's a little easier to see. Right there, okay. And then we'll move this guy a little bit. Take a look at that, right? So see all this ringing, right? And which is obviously not here, right? Everything else kind of matches, but you see this ringing, and that's really an artifact that the square pin and the adapter adds, right? So the common mode rejection actually degrades if you start adding stuff to it. And the point is, when you design these boards, especially if you're doing very, very high speed GAN, you really have to think about your connection points. Even with the best equipment possible, you'll still see issues like this. And the problem is you won't have other reference designs to test again, right? So this will be your golden design, and you'll try to fix this problem for months without knowing that it's just a measurement issue, which you could have solved anyways, right? So to summarize, I just want to say, whenever you're working on GAN or very, very fast switching, try and use a connector like this, which is nice and shielded, really tight layouts, right? You start adding stuff to your layouts and measurement systems, it just degrades the measurements really, really badly, right? And you can see that right here. Even with the really, really good products, you won't be able to make those measurements if you don't do good layouts and good measurement practices, right? So we'll stop this section as this, and let's go look at the current now.
Find out more at Vicom's website.